So now also we discussed how we like how entire thing came from console level application up onto the full blown web application. That's also we discussed. So now we are going to take it from forward today, how we can deploy these created services, how this came all the way. Okay, because knowing the history is important. Sometime when you just landing it today level, then you have a problem to understand if you are going to work on some older project, or because there is no guarantee when you deploy to the project will use all those latest technologies, right? Sometimes you may go to a company where they have like a decade old technology, because some project it's really hard to migrate. There are companies run the ERP system which is probably 3-4 decades old. Okay, because migrating is a nightmare. They don't even think about it. And the other side is, if it is working, if it is serving their purpose, there is no reason to migrate. As long as it's working, it's fine. Okay. So, like we discussed, we came from standalone application to all the way to web application. But this didn't came overnight. There was so many process to do it. Right? It came, we created a service, then we created SOAP services, then it moved to the HTTP, then we went to microservices and so on and so. Now, if you take like 3 decades or 2 decades ago, when we develop a system, right? Let's say that some company need a system, we always need to give an infrastructure diagram, architecture. What we need to do. Right? Few decades ago, I was involving in not few decades, like probably 15-20 years ago, I was involving in web application development on one of other apparel organization. So with the architecture, we had to propose servers. Right? We proposed 5 different servers. One for the web server, database, application server, and mail server, and for the proxy. Right? We had to create data center here in Colombo with all those servers. Now just imagine you want a server. So now getting a server means that hardware box itself. Okay? So you need to get the quotations, and you need to get the pricing approvals, financial approvals, and then you order it, then shipment comes, then come here, and because servers is not something hanging on the shelf to like someone come and buy it, right? Servers are coming for a specific requirement. So number of cores, memories, and everything is matters. So then coming and setting up, and then we need to go and install it, operating system install, then network provisioning, security setup. All those things take at least good to 1 to 3 months. Right? If it work in the 3 months, that's good, but it take more than that. More than that time, the problem is the like pain we have to go through. Then we need someone who's dedicated to these servers to maintain and take care of these servers. Just imagine now setting up this type of server setup, right? You have a DB server, right? So now DB server crashed. Now entire system is down now, unless you set up something redundant. So now need the other redundant DB server. Okay. So now how deployment works? So we deploy this on the local machine. Develop on the local machine, and we build, and then we copy these to server. Okay. In this type of basic setups, you don't have redundancy, you don't have a DR strategy, you don't have a scaling. When the resource come, okay, you have a more servers to go, right? Probably we could have to think about vertical scaling, but not the horizontal scaling, right? Those are the problems. But for those days requirement, that was enough, right? Those days requirement, that was enough. For example, now you have almost every family have some sort of a vehicle, at least a motorbike, right? But if you think like 4 decades ago, probably 1 or 2 family in the entire village have some sort of a vehicle. But that was okay for that lifestyle. That is not okay for today's lifestyle. So even today, for some villages or some rural area, you cannot go to, if you want to go somewhere, you cannot go to the road the time you want. You have a specific bus schedule, right? First bus is 9:30. If you miss the 9:30, then 10:30. If you miss the 10:30, then 11:30. Right? Still that is there, but that is okay for their lifestyle. They used to it. Likewise, these spec and these things today, when you think is, you can say, okay, how you can run a business with this. But that's how business was going. Now, when these things evolve, what happened? So now let's draw it so then we can understand. So what is our setup? We have on premises, right? On-prem. Let's do a roof to identify. So you have a bunch of servers, right? Like we discussed that day, we have external connectivity, probably multiple ISPs and so and so. So we have a connectivity and we are going through that. So this is an on-prem data center, right? So now the next version was this. So now we discussed, when if your database server failed, what happened? Then you lost everything. You have backup, but until you install it somewhere and get it up, it's crashing. Your system doesn't work. Not only database server, no matter what server failed, that same thing going on. So what the next generation was, we buy some bigger servers, okay, install something like virtualization on this, like a hypervisor or something, and then you create your mesh servers on top of this. Okay, so these called VMs. Now, if you need a new server, this model, it takes 3 months minimum. This model is like a few hours, even less than that probably. Why? Because you are running a big giant box, right? So now what you can do is, for the redundancy purpose, that now you can say, okay, what happened if the RAM damage or a motherboard damage? Then you're going to lose everything. But to that, you can have other server like this, right? There are some people called blade server. Blade server is because of the shape of that, but let's forget it, right? So you can create you can get one or two more servers. So no, you can create more VMs. Okay. However, each VM work as independent server. But you have to understand this. Now there are 4 servers. How many network cables running into the switch? How many network cables running into your switch minimum? 4. Okay, there can be redundant networks, but there are at least minimum 4. Here, minimum 1. Why? Because you have only one physical server. So there are so many virtualization and mapping and switching going on this application level, which is not in the hardware level. Okay? So now if you have 32 cores on the original server, then you can probably spin out 32 different VMs, right? 32 different VMs, right? So, but we'll see in like probably in 30 minutes later how we can spin out more VMs than the cores you have. You can do it. Okay. So now this has again, but we solve bigger problem, but still we have some problems. It is not that completely solved. So what are the problems we have? We have to have a separate operating system. right? And we have to do a separate patch update, separate security update. We need administrator to taking care of it. Everything is same. The only best side is once something crash, you can have even image of it, the installed image, right? So because then let's say this is your particular particular VM, you can take an image of it, and whenever you need it, you can get that image back and restore. That is possible. So if you like zoom in this part, how this exactly works, so you have this infrastructure, right? You have the infrastructure. On top of the infrastructure, you install something like a hypervisor, right? Virtualization software. Okay. So on top of this, you create this VM, right? On top of this, you create this VM. Now inside the VM, you have again your guest operating system, right? And then you might have your application server, whatever. Then this you have a service. Okay, so this is how, if you zoom in, this is how you looks like. So now this is also okay. But if you really think how these things evolve, right? So we solve a current problem, we have a problem and we solve the current problem. And then when we little go with that problem, we feel, okay, this is not enough now, right? So we didn't build a car which can run 300 kilometers per hour at the first go. First one probably 40 kilometers per hour, maybe less than that. Then 60 kilometers per hour, then 100 kilometers per hour car, then 150, then 200, 300. That's how it goes, right? So we solve something and then we feel, okay, this is not enough, so we need to go more. So this is the same way this happens, right? We had this, we lived with it, the requirement changed, so this came. So now we discuss in around 2013, I told few things happen on like same time, right? If you really think the history also same, right? Newton found something and someone took it and go for things happen in order. So in 2013, so Martin Fowler theorized the microservices, right? What the microservices he did, he got like his concept is taking a big system and divide into multiple subsystems. Okay, we are going in detail about microservices and best practices and everything. For now, you think, so let's you have a ERP solution, you divide into few other services, right? What we running here is a microservice architecture. We have 150 to 180 plus services running on different purposes, right? So we are going to discuss this separately. Microservices came up with the concept, if the microservices need to run properly, you need to have one service per host. Okay, so like something like you have your own home kind of a thing, right? No one can reside in your home, no visitors, right? No boarding places. You have a dedicated home for you. Okay, so now this model, what happened? If it's application server, you run few servers here, few services here. So now if something crash, maybe it caused to other one, because if one service taking more memory, then other service suffer it, right? So let's say one service has a bug, then others might suffer it. Okay, so that problem was there. But in the microservices, now this is okay, because in this model you have a one or two services, this model. But when you go to microservices, it divided into 30 to 20, probably 50, 60 services. So now it is easy, if everyone in the same server, it is easy someone to crash someone else, right? So if you take our cluster, we always say sometime some services cause CPU hogs, right? So we discussed when it comes to Microservices, what is a CPU hog and how would that happen, right? Some services cause CPU hogs. We always say CPU, this is okay. CPU consumption, this is okay. We call shark teeth. Shark teeth is perfectly fine. If it is 100, this is perfectly fine. But the broken teeth is problem. So if you have something like this, that's a problem. That means that service is under stress, suffering something. Right? So now the problem is, if this is this stage, when one service caused this, all other services share that CPU is going through this CPU throttling. So these type of inherent problems are there. But what happened typically, that's why I always encourage you to learn properly, the right way, intention. What is the problem is, for example, microservices, don't learn microservices. Learn which problem microservices solve, how it solve, what are the strategies they brought up. Then you don't do stupid things. Because I have seen even enterprise projects. I have seen enterprise project, this is a microservice project, but they run on a Tomcat. Right? They have one server, the Tomcat installed on it, they have deployed 10 or 20 services on top of that. Right? So they can argue saying, okay, microservices mean domain driven some sort of architecture, so we did it. No, microservice has an end-to-end. How you should design, how you should code, how you should versioning, and how you should deploy. Okay, but if you're missing one piece, you cannot get the real benefit. Okay, so now what happens is they have something called one service per host. So if we have 100 services, now you need to deploy on 100 different VMs. Okay, so there is a place, actually I did this because they had a microservice based architecture solution. They were running into problem because they are using a one shared host. Okay, so converting this to a next level of the proper running is kind of a 6 months to 1 year of refactoring. So now we need intermediate solution. So intermediate solution I gave, they had 10 services, 13 services, we create 13 different VMs. So now major problem they suffered, crashing under the load, is not there anymore. The system is running peacefully. But did we do the exact right thing? No. But they're on the way to that. But they came out from the problem. So this, when this coming from the microservice architecture from Martin Fowler's, there was a containerization also going on. Containerization means they were talking about how we can minimize size of this VM and make it independently work. And with that, they emerged a technology called Docker. Docker means nothing but is kind of a next evolution of the VM. It's a VM, right? That means it's not a VM, but it's virtual. Okay, you don't have a physical box. It's a 100% virtual, but it is not as a VM. Why? Because VM, if you get the VM has a full-blown operating system. If you get Ubuntu, I don't know whether you guys did it, probably not. So when we learned, there was a services they ship Ubuntu CDs. When the Linux, they want to popular the Linux, so you came up in the era that you can download Ubuntu, right? So we had to order Ubuntu. So then there is a CD coming in kind of in 2 weeks or 3 weeks later, there's a CD coming. And that was a kind of hobby, collecting those CDs, every version. So if you get Ubuntu, the DVD or a CD come like a 2 GB to 3 GB. When you install Ubuntu, it take like a 4 GB of hard drive space. Docker also has Ubuntu, but only the kernel, depending on what you doing, right? This kernel is less than probably 30 MB. Right? Kernel is less than 30 MB. But if you install the operating system, It costs like 3-4 GBs. So now what they did, if you have a VM that has a full-blown operating system, but when it comes to the Docker, they only give you just a basic operating system what required to run the machine. That's it. Right? So why Ubuntu? Let's take the Windows. Okay, let's get the Windows. I told, like, when I usually run these training programs, what I do is I remove the operating system from your machine and put the Linux on that without the UI. Right? The Linux operating system without UI. So you only have a shell. So you become a serious software engineers which know the commands. Okay, so someone can argue this is 2025, why you need to know the commands? You need to know the commands. It doesn't matter 2025 or 2050. Something might crash and it ended up with a terminal, which you don't have a ChatGPT or the Google. Right? So what the operating system mean, on top of this terminal, you have a GUI. And you have a bunch of other tools, searching tools and organizing tools, so many other tools. That is why you have this giant operating system. So operating system has a different flavors, right? For example, some is Debian, which is Ubuntu and type of thing. Some are Fedora, where Red Hat and CentOS is going, right? If you get the Linux, Windows is proprietary and Mac OS is proprietary. So now what the Docker did, they took the kernel out of this operating system. Not exactly the kernel. You can think the operating system which is just what you require to start up a machine. Okay, just what you require to start up a machine. So now when you have that, if you need something, you can install. For example, you have a requirement, your Docker need to telnet to other Docker or ping to other Docker. The ping tool, the ping command what you do in a machine, that is a tool, that's a program. That doesn't come with this one. You need to install it. When you install it, it gets bigger. But if you need it, you will install. If you don't need it, you don't install. That's the concept. Right? So now they have a small operating system, and then you can install, customize install. You can install whatever you need on top of that, and then you can put your application. Right? As a result, this Docker might like 50 megabytes to like a 200 megabytes maximum. Now what happened? Since it's a smaller, the loading time is faster. The startup time is faster. And if you get VM, if it take like 1 minute to 2 minutes to start, the Docker might start within 15 seconds. Why? The bags it has to carry is very small. Right? So that is how Docker born, from on-prem to VM and the Docker. But there was an intermediate state between this VM and the Docker. Right? There is an intermediate state here, VM and the Docker. So there is something like this, where what we did was we shifted these VM to the cloud. Right? We shifted this VM to the cloud. When you say you create an EC2 instance on AWS, it is nothing but you create a VM. They don't give you a dedicated machine on their data center, no? Right? You probably sharing, let's say 9 of you created VMs, probably you are sharing a same hardware box, which you don't know, but you feel you have 100% control on your machine. Right? So this is an intermediate state. That is why we don't consider that as a stage of evolution. This is called lift and shift. You lifted your VM from your on-prem data center and put on the cloud. Rest of the thing, same. It has a dedicated operating system, right? The only thing is, the guy who's supposed to stay here, hang out here to maintain this no longer required. But you need to have operating system, you need to pay for the operating system. If you create a EC2 instance on the cloud, just see the pricing, EC2 pricing. Set the operating system is Amazon Linux or something. Probably price will say $0.2 per hour. Just select the Windows. It goes up. Why? In the cloud, you cannot install a crack version. Right? This is real operating system. The license cost is there. Right? So this is the kind of intermediate state where you lifted from here and shifted to the cloud. But not a stage of evolution of this deployment. Okay? So now from Docker, we are discussing later. So it's have so many next level of going. Okay? So now I'm keeping a vacuum inside here. So where the Docker hiding, right? So with the Docker, there were so many things came. So now the bigger problems now solved. That's super quick. Service can scale the way you want, right? If you need like 5, you have 5. If you need 10, you can 10. One something kills, next one come up super quick, less than 30 seconds uptime. So many problems sorted. But if you are not going to the cloud, again you need to maintain on-prem data center. But not painful as this, but some sort of a Kubernetes cluster or something on the on-prem. And even not on-prem, let's say cloud, you are running on EKS or somewhere, you need to create Dockers, you need to run Dockers, and so and so. Again, we start to think, now developers has to think about that also, because I told so many things happen same time. Microservices came, containerization came, and there was a kind of new job role came called DevOps. Right? So far, we had developers and we have operation people to run the infrastructure. Right? Developers and operations people. So, but when you go here, it's more like creating a Docker for your service or something. It's also part of a dev. You need to run in the local, you need it. Things like that. So, DevOps born. Okay, there's other stories behind DevOps, but mainly we need the DevOps. So now what happens is, so still you need to run some sort of a server to your machine. Now developers has to focus on that. So there was a new concept came called serverless. There is a very famous problem solving technique in the world. That's the most efficient problem solving technique. Let's say you have a problem, it's a big problem, you're suffering day in and out and you don't know how to solve it. Just remove the problem. Then you don't have anything to solve. Okay? So server is the problem, we remove the server. So now nothing to maintain. Okay? That's one organization. I provide a lunch, free lunch, buffet. Right? If you are not taking the lunch, there is some money come to your account for that per lunch because you bought your home lunch. So software engineers are smart. So what people start to do is they're saying, okay, I'm not taking the lunch today. He's absent. I'm consuming his lunch. So I get the lunch plus the money. There are so many proposals came to solve this problem. Right? The one came is give a token. Then people say, okay, these are software engineers, these are professionals, everyone not doing the mistake, why they have to penalize and carrying a token and going and taking this and so and so. So that was out. So there was a, to say, track using like high techs. It's stupid, like it's your lunch. Why you want to like using high tech and track whether you taken the lunch and when you like going the next time giving alarm or something? That's bad, right? But someone came with the smartest idea to solve this problem. They said, okay, from next month we don't give the lunch. So no one is stealing it. Nothing to solve. So, but they did is, if you not take the lunch, you get some money now. They calculate that for the whole month, added to salary. Right? So 2 decades later, everyone joining to that organization assume that lunch amount is in their salary. So that's how solve the problem. Remove the problem, then you don't have to solve it, right? Actually, I use the technique many times. It's working. So serverless mean you remove the server. So now you don't have any pain of managing it, handling it, provisioning memory, no CPU hogs anymore, nothing. You only focus on development, implementation. But there is a truth behind this. It is impossible to run your program without a CPU memory. It is impossible you to get the CPU memory without infrastructure. You cannot create a application CPU. No? There are CPUs, virtual CPUs, but in theory, but CPUs are based on a real CPU. Okay, it is not you can invent CPU on your code. So, though we call serverless, though we say we don't have a servers, but in theory, you cannot do it. There has to be a server somewhere under the curtain to support this. So what actually happens is, when you say serverless, the real meaning is there is a server, but you don't manage it. You don't worry about it. Okay? So this is given and handled by your cloud service provider. Right? You don't even specify the Docker specification. That doesn't mean you cannot. If you want to set up your custom image for the serverless, saying, okay, I need the Ubuntu, I need this particular files in this particular location, you can create your custom Docker image and tell cloud provider to, hey, don't take your Docker, give it my Docker. But what you did, you just abuse the serverless concept. Right? You're going back to this one because you are maintaining your Docker now. Technically possible, but you violated the concept. Right? Because let's say to your application to run, there has to be a var log abc directory. When that is not there, that is how your code was written. Right? So now you go to serverless, you cannot do it. So someone come with a brilliant idea, no, we can do it. What you need to do is create a custom Docker image and attach to your serverless framework and ask you to run this. Perfect. Brilliant idea, but stupid. Why? Because your design was wrong. You are designing something hard coded to an infrastructure, which you should not do. Okay? So now, from all the way from giant 2x4 hardware boxes, right? Like 50-60 kilogram weight hardware boxes, we came all the way to no servers anymore. Serverless.